Hi students, so here we go for the problem. A hemispherical depression is cut out from one of the face of the cubical wooden block. So consider there is a one cubical wooden block, and from that one hemispherical depression means inside, it just cut it from the inside just consider one hemispherical like this, it is cut. So it is a cubical wooden box such that diameter L of the hemisphere is equal to the edge of the cube. So then it is a cube, then diameter will be this equal. So it will be cut like this, right? So they given this and this are equal. So the height also will be the equal. So diameter is an L and radius will be the L by 2. So diameter means the side of the cube will be the L. So instead of giving the number here, they provided the some variable. Is equal to the edge of the cube. Okay. Determine the surface area of the remaining solid. So what are the surface area? So the cubical surface area plus the curved surface area of the hemisphere. But while coming to the cube, the top and bottom is also added. So total surface of the cube will be finding. But in the top you can see the circular has a no area because it's just cut it out and there will be a vacuum. No surface there. No, the surface of this cuboid is cut. They depressed it. They cut and took out. They said it's cut. So we have to subtract this area also. So first let me write the given that two shapes are there, cube and hemisphere. So side of the cube is, all the sides are equal and it is given as an L, and hemisphere is, the radius of the hemisphere is L by 2. So since both are same, so surface area of solid is equal to TSA of cube. We are considering TSA of cube since the bottom is also added, all the sides are added, plus CSA of hemisphere. And one more thing you have to note, the top, the hemisphere, this circle is an empty, we have cut out, there is no surface area, so we have to subtract that circular area. So minus area of, that circle is the base of the hemisphere, right? Area of base of hemisphere, that's nothing but is a circle, right? So TSA of a cube is a 6a square, the a is the side, plus CSA of hemisphere is an 2 pi r square, minus the one of the circle is, that is hemisphere top, is a pi r square. So now just substitute that value, we will be getting a 6, instead of the sides we will substitute L square, plus 2 pi, instead of the r square we will be substituting, before that we can subtract, right? 2 pi r minus pi r, it will be a 1 pi r. So directly we will substitute 1 pi r square. 2 pi r square minus 1 pi r square is a 1 pi r square. So next step, let me substitute the r value there. 6l square plus pi into r is nothing but L by 2 the whole square, right? So it will become a 6l square plus pi l square divided by 4. So L square is the common, we can take it out. So L square is equal to 6 plus pi by 4 units. So this is the, we got it a general. Since there is no value given for the radius or edge, it is given that. So only this, while making these things, we have to be very careful. We have to see what are the surfaces there and what are the surfaces cut out. Here this circular base of the hemisphere is cut out, that is subtracted, and the other thing, the both curved surface area of the hemisphere and the total surface area of the cube is added. So here we come for the next problem. A tent is in the shape of cylindrical, surmounted by a conical top. So the tent in the bottom, that is a cylindrical shape, and the top is in the conical shape. So if the height and diameter of the cylindrical part are 2.1 meter, so this diameter is the height and diameter of the cylindrical part. So height is a 2.1 meter and diameter is the 4 meter respectively. Diameter is full length is the 4 meter. Then the radius, just consider circle, and radius will be the 2 meter. Okay. And the slant height of a top is 2.8. This slant height is a 2.8 meter. Find the area of a canvas used for making the tent. Canvas means the outside region. So it's a surface area. So here we have to find the curved surface area of the cylinder and curved surface area of the cone, and we have to add. Also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. So rate is also given for meter square. So first we have to find the total surface area, that how many surface we need is there, and that is the what we needed as a canvas. We have to find the rate of the canvas also. So two shapes are there, the cylinder and cone. So the height of the cylinder is 2.1 meter and radius is a 2 meter since we found from here, and cone slant height, which is L, is equal to 2.8 meter, and radius here is also the same, will be there, right? 2 meter. Clear? So they asking about the area of canvas, which is equal to CSA of cone plus CSA of cylinder. So CSA of the cone is the pi RL plus CSA of the cylinder is 2 pi RH. So we can take the pi and r are the common, so we can take it outside and we can substitute. I hope it will be little easy. Pi r and pi r, right? Here the L is the balance, A to H. So pi I can substitute 22 by 7, and the since the radius, both the radius are same, it is possible. If it is different, it's not possible. So radius is the 2 and length is the slant height is the 2.8 plus 2 into the height is the 2.1, right? So 22 by 7 into 2, actually we cannot cancel this, but let us substitute this brackets, and 2.8 plus 4.2, if you add we'll get as a 7, so it now cancelled. 2 into 2.8 plus 4.8 is 7.0 actually. So 7 and 7 cancel, and 2 into 22 is 44 meter square. So the canvas we needed is in a 44 meter square. So cost of 1 meter square is rupees 500. Then the cost of 44 meter square is 500 into 44, which is equal to 220. This is the cost, 22,000. So therefore canvas will cost rupees 22,000 for making a tent. So here's the next question. A wooden article was made by a scooping out a hemisphere. Scooping out means it's also just depressed, taken out a hemisphere from each end of the solid cylinder. Consider a solid cylinder, from each end it's scooped out. It will be like this. Yes. If the height of the cylinder is 10 meter, the height is given as a 10 meter, and its base of the radius is a 3.5 centimeter. Find the total surface area of this article. So this article, the inside this area, we will be calling it as a CSA of the sphere. So 2 CSA of the hemisphere, 2 hemisphere, and this region we call it as a CSA of the cylinder. So top and bottom is actually, it's nothing that, it's a space, so we can leave that. So two shapes are cylinder and one is the hemisphere. So cylinder height is a 10 centimeter and radius is equal to 3.5 centimeter, and hemisphere's radius is also same. If it is different, we have to represent by capital R or R1, R2, something like that. So surface area of an article we can find by just adding a CSA of cylinder plus 2 into 2 hemisphere, others 2 into CSA of hemisphere, right? So CSA of a cylinder is a 2 pi RH plus 2 times the CSA of the hemisphere is a 2 pi r square, right? So here you can see that 2 pi r, and here one of the 2 pi r common we can take out. I hope it will be easy. So 2 pi r, and here is balanced h plus here 2 and one more r, right? Now let me substitute 2 into pi as a 22 by 7 into r is a 3.5 into height is the 10 centimeter plus 2 into radius is 3.5, right? So the 7 and 3.5 is for a 0.5, right? And we will get this 2 into 0.5 is the 1 into 2 into 2 is 22, and here is a 10 plus 2 into 3.5 is the 7.0. Let me write 7. So 10 plus 7 is 17. 22 into 17, 22 into 17 is 374 centimeter square. So this is the surface area of the article. Therefore total surface area of the article is 374 centimeter square. Clear? Thank you.